Welcome back to my channel, everyone. Sri Tips here, and the day has come for me to cash in my savings account here. I have another big debt that came up, so what I'm going to do is, this is my bottle of catches. I call them catches. They're used to hold gold jewelry together, pieces of bracelets and necklaces and things like that. And what I'm going to do is go in here and save out some of these big pieces. And then what we'll do is I must refine the rest of the smaller pieces. So I'm going to dig through this now and save some of the bigger pieces for reuse by people who need them for their pieces of jewelry. What these are the clasps that are used to hold together chains and necklaces. And over the years, as I refine the scrap jewelry that we buy here locally, my wife gets most of it for me. But as I refine the jewelry, the bracelets and necklaces, I take the catches off of those pieces and I save them up. And this is about 4 years accumulation of saving the catches off the jewelry that I refine. I've completed the sorting process. Here I have a small bottle that has some charms and things that I'm saving. And here are some pieces that are going to be saved. A little butterfly charm and some earrings. So I just put them in this bottle. And we'll save this. Next I have the pieces that I selected that I want to save. And these are the larger pieces that can be resold and used again to repair people's jewelry. And now what we'll do is the rest of these pieces, we're going to refine this into high purity gold. I've got a melt dish that I used last time I did these catches. And you can see there's a bunch of springs in there. But there's also some pieces of gold that got left behind. So let's put this dish on the scale here, zero it out. Now we're going to weigh this material and get it ready for refining. Alright, looks like we've got 211 grams. Now I've got some other pieces here that I've kind of sorted through, and we're just going to add this to our crucible. We've got 219 grams, and what I think I'll do here is we're going to call that 219 grams of 12K gold. Let's take this out on our melt table out here and start melting this gold so we can then quart it with some silver. Here we go. $12K gold is 50% pure gold. So we're going to have about, what is that, 110 grams roughly of pure gold from this refining. If we've got 110 grams of pure gold in our material, then we want to create an alloy that is 1/4 gold and 3/4 silver and base metals. So we multiply 110 by 3, and we get 330 grams of sterling is what we need to inquart our gold. Someone asked, why don't we use pure silver to inquart the gold? And the reason we do not use pure silver is because this silver has already been refined to high purity through our silver cell. So we don't want to put it in our inquarted gold and have to run it back through the cell a second time. Instead, what we want to do is use sterling silver. I have a flatware set that I bought recently at an estate sale. We're just going to use this. We need 330 grams of sterling silver to go into the crucible with the gold that we have melting. That's 311. That's close enough. Once the gold is molten, I'm going to hit it with some borax flux there, try to get the skin off the top of the molten gold. And now what we'll do is we'll introduce the silver that we've selected for the inquartation into the melt dish and combine it and alloy it with the gold in the melt dish. Many of you may be asking, why is he adding silver to the gold? He's trying to purify the gold. Why add silver? And the reason we're doing this is called inquartation. The root word is quart or quarter, and we're making an alloy that is roughly 25% pure gold and 75% base metals and silver. And it's called inquartation, so we want 1/4 pure gold in that alloy with 3/4 silver and base metals. But why, you must be asking, why are we doing this? And the answer is, if we tried to put that karat gold in the boiling nitric acid treatments coming up in the next step, nothing would happen. The gold would just sit there. The high karat gold would shield the silver and the base metals in the alloy from the acid. But when we reduce the amount of pure gold in the alloy down to around 25%, then and only then the boiling nitric acid treatments that we're getting ready to do will be able to penetrate to the core of each piece of the inquarted gold. It forms a honeycomb structure in each piece as it goes, and it will be able to completely remove all of the silver and all of the base metals down to the core of each piece of inquarted gold. I refine silver and gold. The first step in silver refining is to dissolve the silver in hot dilute nitric acid. So why not use it to inquart my gold? Here I use a graphite rod to stir the metal to create an even alloy throughout the charge that's in that crucible. And stirring it longer, I believe, is better than not stirring it long enough. And my rule of thumb is when it feels like I've stirred it long enough, then I stir it for 20 more seconds after I think I've stirred it long enough. And this is to create a nice even alloy that will dissolve uniformly in the hot dilute nitric acid treatments that we have coming up. Now that I have a consistent charge of metal, I'm going to pour it into a container of water. The container must be metal. It's a stainless steel soup pot. If we use plastic or glass, the metal stays hot even after it hits the bottom of that container after going through the water, and it could break a glass container or melt through a plastic container.
Let's dump the tap water off of here now. I'll transfer the pieces of gold down into this beaker carefully. Oh, metal and glass, not a good combination. I'm going to rinse all the tap water off of here with some distilled water because we don't want tap water in there during the next reaction. We're going to add nitric acid, hot dilute nitric acid to this, and pull the silver and the base metals back out of there now. The nitric won't touch the gold, it will leave it behind. And this does a fantastic job of cleaning the gold up, adding silver to it, and then pulling the silver back out with hot dilute nitric acid boils. Here's our unquarted gold in a 2-liter beaker. Now what I'll do is add some distilled water, about 200 milliliters. Next, I'll add an equal amount of nitric acid, and we'll start removing the silver and the base metals with hot dilute nitric acid boils. I'll put this up on the heat now and let this react. That's nitric acid boil number 2. The second nitric acid boil is complete. So now what we'll do is we'll pour the silver nitrate solution off here into my silver jar. The silver jar has pieces of sterling silver in there to consume any remaining nitric acid that may be in this blue liquid that I'm pouring off. Now what we'll do is add a little bit more distilled water to this. Set it back up on the heat. Now we'll add roughly the same amount of nitric acid to form a dilute nitric acid solution in here. And this will be nitric acid boil number 3. Once all the excess nitric acid has been consumed by the pieces of silver in here, I recover the silver from this liquid, and I've got another silver jar here set up. And what we do is we put we filter the solids out of here, and then once we get all the solids filtered out of this liquid, I'll add the liquid to a separate container, and then we'll add pieces of clean copper to the liquid in the clean container and cement the silver out of this solution down here. And notice that there's pieces of sterling silver left in here. That will tell me that all the excess nitric has been consumed out of this container. Once I have the silver cemented out of that blue liquid, I rinse all the blue liquid off of it, and then we melt it up into granules like this here. This is silver that's about 99 to 98% pure. I've melted the cement silver and poured it into water to form these granules. And then what we do is we add the granules to our anode filter basket up here on top of the silver cell. And we pass an electric current through those granules. The silver dissolves and comes down in here, travels through that silver nitrate electrolyte, and then plates out as absolutely pure elemental silver on the inside of our stainless steel cathode. Third nitric boil is complete. We're going to add this liquid to the silver jar. It's going to contain silver, so we want to save this liquid. Add some distilled water, put it back up on the heat. Now we're going to add some more nitric acid. And this will be our 4th nitric acid boil. Nitric boil number 4 is complete. So we're going to pour this off out of here now. Oh yeah, the gold is looking real good. Nitric boil number 5. I'm going to add some more pieces of burnt flatware to my silver jar up here. What this does is this will consume any excess nitric acid that's in the liquid that we're pouring off out of the gold refining jar. Nitric boil number 5 is complete. As long as I can see color in that liquid. See how it looks blue still? That means we're still pulling silver and copper out of there. We're just going to pour this right into our silver jar now. What we want here is a solution that appears colorless. When we're done with the boils, add some more nitric here. And this will be nitric boil number 6. Nitric boil number 6 is complete. What we're going to do now is pour this off. And I'm going to save the acid down here in this little jar. I'm going to add some more water. Put it back up on the heat. And now what I'll do is put in some more nitric acid. And this will be nitric acid boil number 7. Alright, this 7th nitric boil is complete. And what we're going to do now is pour off this acid. We want to save it because it can still dissolve silver and base metals. Notice how clear the acid is, colorless. It's even got a little bit of a tint of yellow to it, so that's probably a good indication that all the copper as well as the silver has been removed from this gold. I always do that. I always clang the beaker against the dish for some reason. Now what I'll do is I'm going to add just a little bit of distilled water. And we're going to boil this in some water for a few minutes, just enough to get a little bit more of that acid off of there. It's been boiling in the distilled water now very gently for about 5 minutes. What we're going to do now is pour this off into my silver jar. Someone asked, why am I doing this? Why am I boiling it in water? And it's just to help rinse a little bit more of the nitric acid off of here before we go to the aqua regia stage. Should be some nice clean gold right there. Now, it's important to point out that the gold in this beaker right now, after these nitric boils, is very close to 3/9 fine, just like it is. Alright, the only way to get it to 3/9 fine is to do a refining on aqua regia. So what I'm going to do here is I've got hydrochloric acid. I'm going to fill this up to about the 400 milliliter level with hydrochloric acid. I'm going to put a few drops of sulfuric acid in here. The sulfuric acid will combine with any lead that may be present and precipitate out the lead as lead sulfate, and then we can remove it by filtering. I've got a beaker here. I'm measuring out some nitric acid. Should have about maybe 3.5, maybe 4 troy ounces in here. So we're going to go with about 35 milliliters of nitric acid. And just pour this right on in and dissolve our gold now. If you look down on the bottom of the beaker down there, we've got some granules of gold that still have not dissolved. The solution is boiling vigorously and all the fume production has ceased. So what I'm going to do is add just a little bit of nitric acid here, not even half a milliliter. And you got to add this stuff real slow when it's like this. Otherwise, we could get a vigorous boil over. What this is called is incremental nitric acid dosing. We're adding just enough nitric here to just dissolve the gold and no more. And if we do this correctly, when we're done, there will be no need to rid the solution of excess, because there will be no excess nitric to get rid of. Incremental nitric dosing, one of the most valuable refining techniques I've ever learned, second only to inquartation with silver. Here you can see the gold is beginning to dance on the bottom of the beaker. That's because most of it has dissolved and there's just some light pieces in there, and they're reacting with the nitric acid, and they're starting to dance around off the floor of the beaker in there. So we're pretty close to having everything in solution. I think we've got just about everything to go into solution here. Let me turn this camera off, get it out of the way. And what we're going to do now is pull this down off the heat and let it cool off. I've got some ice. We'll cool the solution down with some ice made from distilled water. Let's dampen our filter. Now we're going to filter our solution. Notice it's got some cloudiness going on. That's due to silver chloride that's in there. Here's what our filter looks like. What I'm going to do now is you can see down here the solution is a little cloudy. Probably has silver chloride. So what we'll do now is we're going to pass this liquid through the same filter a second time. Let's see here. Just wanted to show you here the second pass through the filter has cleared our solution up nicely for us. Here's the original solution, first pass. Here's the solution after the second pass through the same filter. And what happens here is the filter gets loaded up with particulate. Once it loads up, it's able to filter out even finer particles from the solution. So that's the benefit of passing the liquid through the same filter a second time. Here's our nice, beautiful, clear gold solution. What I'll do now is set up this other flask. And there's still some gold in this filter, but I do not want to rinse the filter because it could dissolve some of that silver chloride in that filter and put it in our solution. So I'll set this up, pour some water through here, get the gold rinsed out of the filter, collect it in the flask, and then we'll add it to the waste treatment jar for recovery. Adding some distilled water, and we'll rinse the gold out of this funnel and out of that filter. And then now what we're going to do is transfer our gold solution into this beaker. I use ice when I precipitate 2 or more troy ounces. Because it is an exothermic reaction, it gives off a lot of heat. Using ice keeps the solution cool during the precipitation. Ice is made from distilled water. Here we go. We're going to do our first precipitation with Stump Out by Bonide. Is sodium metabisulfite. Got it at Ace Hardware. Here we go. First spoon going in. Just going to start adding spoons in. Should take about 6 or 8. That's 2, 3, 4, 5, and there's 6. Let's see where that gets us. Here you can see there's a layer of pure gold down on the bottom of the beaker. Now what we'll do is give this thing a stir. I'm just going to shake it up a little bit. Let's do a Stannis test. Make sure we've got all the gold precipitated. That's just a piece of filter paper that I cut into little strips like that. This is Stannis chloride testing solution. You can see we get 0 reaction. That means all the gold has precipitated out of this solution. Here's our pure gold. It's been allowed to settle for about half an hour. Now what we'll do, I'm going to pour off the solution into this temporary waste container. There's the gold. Let's get rid of this waste solution now. Here's what the gold looks like down in the bottom of our beaker. I'm going to give it a rinse with some water. Make sure we get all the SMB off of there. We're going to give it a hydrochloric acid rinse. Let's pour that off into our waste container. Another quick water rinse. Pour this off. Settling out pretty good. It's looking pretty good so far. Now what we'll do, I'm gonna add some hydrochloric acid. I'm gonna set this back up on the heat. And we're gonna dissolve this a second time. Let's give it a shot of sulfuric acid. I always add sulfuric acid whether I suspect there's lead in there or not. Hurts nothing, costs almost nothing, provides a big benefit. Measuring out some nitric acid here. I'm going to go with, I guess, about maybe 40, a little over 40 milliliters. We're going to add this right on in and start dissolving our gold a second time. The gold is almost fully dissolved. It was in a finely divided state and fairly high purity right there. So while we're waiting for that to dissolve, what I'll do is this is the solution that I pulled off of the filter, and what we're going to do is add this to the waste container now. I'm going to add just a small shot here of nitric acid. It's about 1.5 milliliters. If we get the rest of this gold to dissolve for us. Look at the beautiful color and clarity of this solution. I'm going to turn the heat off now. I think we've got everything to dissolve. Let's see what it looks like under here. Yeah, everything's dissolved. I'm going to pull it down off the heat and let this cool off. I've allowed the solution to cool, and I've added some ice to cool it down even further. Now we're going to go ahead and filter our solution. It's crystal clear. without any traces of contamination, but we'll filter it anyway. That solution was real clean. Here you can see there's very little, if anything, in our filter. So what we'll do now is let's get our gold in this clean beaker right here. Here's our solution. It looks cloudy. That's only because there's condensate on the outside of the flask. It's clear and bright, just beautiful. I'm going to add some Stump Out by Bonide, which is sodium metabisulfite. We're going to precipitate out the pure gold. I'm just going to add 6 spoons in rapid succession here. 1, 2, 3, 4, and that's 5. We might be there. Let's stop right there. All right, let me get a stannous test. Got a piece of filter paper. Dip it in our solution. Let's see if we got all the gold precipitated out. And no, we do not. See that? We're still getting gold in solution, indicating with our stannous test. So now we need to add some more SMB, or Stump Out. All right, here we go. Some more spoons of Stump Out. Try to get the rest of this gold to precipitate. That was 2 more spoons. I think that should do it. There's a half of one. That white foam on top tells me that we're pretty close to having all the gold precipitated out. Let's do another stannous test. And there you can see negative stannous test means we've got all the gold precipitated out of our solution. I've allowed it to settle for about 20 minutes. Pour off the waste solution now. Alright, here we go. This is what the double refined gold looks like down in our beaker. Rinse with some water. Alright, we're going to rinse with a little hydrochloric acid. Let's get the gold in our melt dish. Now let's take it over here on the melt table. We'll melt this up into a nice bar of gold for ourselves. Here's our nice pure gold bar. Looks spectacular. Little piece of flux on the corner right down there by my thumb. That's no problem. We get that off with some dilute sulfuric. And this is a double refining, so it's going to be high purity. Let's see what we got for a weight on this thing. I was expecting 110. We've got 121. I was kind of expecting a higher yield than normal because the number of catches in there that were 14K were probably greater than the number of 10K catches. So my interpolation of 12K was a little off to the low side. And I made an error when I calculated the amount of sterling silver needed. But it turned out all right. So we've got 121.2 grams of pure gold. That's 3.9 troy ounces of high purity gold. This should go a long way in paying my debts that I owe. And I would like to thank everyone for watching. This will conclude the video.